What if one invisible force could turn night into day, spin factories to life, and connect the entire planet? For most of human history, electricity was not something people used. It was something they feared, studied, and barely understood. And yet, once humanity learned how to control it, everything changed. Today, we flick a switch and expect light. We plug in a phone and expect it to work. We live inside a world built on electricity so completely that it is easy to forget how strange that would have seemed just a few centuries ago. Before electricity powered homes, cities were dim after sunset. Work stopped when daylight faded. Communication moved at the speed of horses, ships, and trains. Then came a series of discoveries that slowly unlocked one of the most powerful forces on Earth. But electricity did not arrive as a single invention. It came through centuries of curiosity, accident, argument, and breakthrough. And the biggest question was not just what electricity was, it was how to make it useful. Long before modern science, people knew about static electricity. Ancient observers noticed that rubbed amber could attract small objects. It was a strange trick of nature, but nothing more. For a long time, that was where the story ended. Electricity seemed like a curiosity, not a force that could shape civilization. Then scientists began to ask harder questions. In the 1700s, experiments showed that lightning and electricity were connected. That idea was shocking in every sense. If lightning was a form of electricity, then this invisible force was not just a laboratory trick. It was part of the natural world on a massive scale. Benjamin Franklin's famous kite experiment is often remembered here, though the exact details are debated. What matters is the broader fact. People were starting to realize electricity was real, powerful, and everywhere. Still, understanding electricity was one thing. Controlling it was another. That changed with the development of the battery. Alessandro Volta created the first true battery around 1800, giving scientists a steady source of electrical current. This was a turning point. Before batteries, electricity could be produced only in brief bursts. With a reliable source, experiments suddenly became much more useful. Researchers could test wires, magnets, sparks, and circuits again and again. A new age of electrical science had begun. And then came a discovery that would open the door to the modern world: the relationship between electricity and magnetism. Scientists found that moving electric current could create magnetism, and changing magnetic fields could create electricity. That sounds simple now, but at the time it was revolutionary. It meant electricity could be generated, not just stored. It could be harnessed on a much larger scale. This is where the story starts to race forward. If electricity could be made continuously, then what could it do? The answer changed factories first. Machines no longer had to rely only on water wheels or steam in the same limited way. Electric motors became smaller, cleaner, and more flexible. Factories could be arranged differently. Production became faster. Industries expanded. Electricity did not just light the world, it reorganized it. Then came one of the most visible changes of all: light. For most people, electricity became magical the moment it powered lamps. The idea of bright, reliable light at the push of a button was astonishing. Streets that once disappeared into darkness could now stay active at night. Shops could remain open longer. Cities became louder, busier, and more alive after sunset. The world's rhythm changed. Night no longer meant total pause. But lighting was only the beginning. Soon electricity moved into homes. At first it was a luxury. Then it became a necessity. Electric power brought fans, irons, telephones, radios, refrigerators, and later televisions and computers. Each device changed daily life in a different way. Food could stay fresh longer. Messages could travel faster. Entertainment entered the home. Work, family life, and culture all shifted around the presence of a wall socket. Yet there was a major problem hiding behind this progress. How do you deliver electricity to millions of people at once? That question led to the power grid. Power stations could generate electricity, but homes and businesses needed it delivered safely over long distances. This required wires, transformers, systems of control, and careful planning. The grid became one of the greatest engineering achievements in history. It linked cities and towns into a shared electrical network. If it worked, modern life flowed smoothly. If it failed, everything felt the impact immediately. And there was also a fierce struggle over what kind of electricity the world would use. In the late 1800s, there was a famous competition between direct current and alternating current. Thomas Edison strongly supported direct current. Nikola Tesla, backed by George Westinghouse, championed alternating current, which could travel much farther with less loss. This was not just a technical debate. It was an economic battle, a public fight, and a race to define the future. Alternating current eventually won for large-scale power distribution because it was more efficient over long distances. That decision shaped the electrical world we live in today. It made it possible to power distant neighborhoods, growing cities, and eventually entire nations. But the real revelation is even bigger than that. Electricity did not simply add convenience to the modern world. It made the modern world possible. Without electricity, there would be no internet, no smartphones, no computers, no modern hospitals, no advanced communication networks, no global supply chains, and no many of the machines that define daily life. Electricity became the hidden foundation underneath nearly every major technology of the last century. That is why this story matters so much. Electricity changed more than homes and cities. It changed human time, human labor, human connection, and human possibility. It took the world from candlelight to constant light, from isolated communities to connected systems, from slow messages to instant communication. And it all began with a question: what is this strange force in nature? The answer took centuries to uncover. But once humanity learned how to use electricity, there was no going back. Because after electricity changed the world itself had to change to keep up.